Let us now discuss different types of structural loads. There are many types of loads that act on a structure. These loads are broadly grouped under two categories, namely static loads and dynamic loads. The dynamic loads, unless dynamic analysis is required, are often converted to static loads with due approximations for simplicity of analysis. To name a few, there are concentrated loads, self-weight, which is of dead load type, live load, snow load, wind load, earthquake load, impact load, etc. Each one of these loads fall under one or the other category, meaning they can be either of concentrated type or uniformly distributed type or uniformly varying type. If something is hanging underneath the beam, it can be considered as a concentrated or point load. A secondary beam transferring load to the main beam is a good example of concentrated load. The self-weight of the structural element having uniform cross-section all along its length is a good example of uniformly distributed load. The uniformly varying load is having varying intensity along the length of the structural element. The variation of intensity is linear in this case. Examples include self-weight of the structural element having uniformly varying cross-section along its length, the hydrostatic pressure, and the earth pressure behind the retaining wall. These distributed loads can be thought of as a series of infinitesimally closely spaced concentrated loads. The total magnitude of distributed loads can be calculated as the area underneath the curve. For example, in case of uniformly distributed load, the total magnitude of the load is intensity multiplied by the span on which it is acting. In the case of uniformly varying load, the area under the curve represents the total magnitude of the load. Any load that is not of regular type can be represented as a generic type. The intensity, or the variation of intensity in this case, is expressed as mathematical formula. In order to calculate the total magnitude of this load, you need to employ integration.